Okay, we're back with fractions here. And we have something called a complex fraction. I don't think you're going to love this, but the first, I don't know how far we're going to go with this, but it actually, at least at the beginning here, I don't know if we're going to get into the real ugly ones, but these two problems are exactly the same. A fraction bar is another way of saying division. So the fraction 2 over 3 is really 2 divided by 3, sliced up into 3 pieces, but it's the same. So what I have here in this problem is really a fraction over a fraction. So, and it's being divided. So if I have a fraction over a fraction, I'm get this, it's the same thing, and we know how to do that. It's keep, change, flip. Now we get to here and it turns into a problem like from last section. I don't know if they factored it down. I like to see it that way, so we cancel the common factors and we get 6/5. So a fraction over a fraction is just keep, change, flip the bottom one upside down. Now, I guess I'll do it. Let me show it so we refresher on this. So 6, so everything on top has now been factored, everything on bottom, so they've been moved over and factored. Well, I can cancel the 3's, I get 4/5. So keep, change, and flip the bottom one. It's the same thing from before. Now nothing is going to, oh no, there is. So I'm going to just go ahead and slash those down like old school style. But they shared a 3. Now across the top I get an 11. Across the bottom I got 14. Now it doesn't change with anything when we start introducing idle no's into the problem. It's still keep, hold on here, they've done it. It's still keep, change, flip. Now we can cancel common factors. I like this. They factored everything down. The x's are common, the 2's are common, and we're left with 3 over y. So we've got a over 8 times 6 over a times b. Now, I'm going to just factor everything. There's everything factored on the top. Now, it's really a times b. It's their factor since they're being multiplied. It's the same thing. So, cancel some common factors. I'm with 3 over 4b. Okay, try another one. You can pause if you want to. Okay, so I've got 2 times 2 times 2p on the top. So I just put them all together. And the order doesn't matter. I move the 8 kind of to the front. Doesn't change anything. We're used to seeing it that way with variables. Now that it's factored, you can cancel pieces, the common factors. So I've got 4 over q. Okay, so now we're going to do some expressions that just have this fraction bar. So it's going to work the same. Order of operations is the same. But what we're going to do is tidy up the top and tidy up the bottom as if they were individual problems. And then we'll get it down to one fraction. So, well, we'll do another one here. So if I'm looking at the top as if it was its own problem, multiplication comes first. If I were looking at the bottom as if it's its own problem, exponents would come first. Now, we've finished tidying up, so we're going to finish the top, I get -2, finish the bottom, I get 6, and then we can just reduce that to -1/3. So I'm going to do the top and the bottom as if they're individual problems. So I've got 6, 3 times 5, I got -15. On the bottom, the exponent needs to be done first, so I've got 9 plus 3. Okay, let's finish the top, I get -9 over 12. So I've done the top and did the bottom. Now, let's go ahead and break it down. Okay. 3's will cancel because they're a common factor. Left with -3 over 4. All right, pause if you want to try on your own. I'm going to have, on the top, I'm going to tidy that up first. It's a 24 on that multiplication. On the bottom, I've got to do the exponent. Now I finished the top. I finished the bottom. Now, if you see, they're divisible by 4, so you don't have to do this unless you don't see it. Those are matches. I'm with negative 5 over 3. Okay. Yeah, I don't know why we need this at this point, but this is a useful truth about mathematics. The negative signs in fractions, you can move it around. It's the same. So a negative on the top could come out to the front. You could move it out front. And then from out front, you could move it to the bottom or vice versa. You can interchange these. It doesn't change anything. Now, I'm not sure why they showed that, but maybe we'll see here in a minute. But I'm going to tidy up the top, and I'm going to do the multiplication. Did they do it? Yeah, they did it all in one step, but let me slow it down. So I'm going to do that one first. Now down here, multiplication is first. I'm going to get a negative 6 minus 2. Now, when you get better at these, you don't have to go one step at a time like I'm doing here. But when you're first learning, I'd really recommend that you do. I see a lot of students think they have it and they don't, and so they'll make a mistake. Okay, I was thinking this like a positive 6 and a negative 2 is negative 12. Okay, but we've got some action going on with addition and subtraction, so I'm going to show that sign. And this becomes negative 24 over negative 8. Now, this is division, so this actually just turns out to reduce down to 3. You could reduce it the way we've been doing, where you break the numbers down, but you could also think of this as negative 24 divided by negative 8, which gets you 3. Okay, so you try this if you'd like. I'm gonna do it. Well, I just told you not to, so I better not do it either. So on the top, I'm going to do that first multiplication on the left because he'd be first. On the bottom, that multiplication. Okay, I'm going to finish the top. Now it's 4 times negative 3. That's negative 12. And I'm going to show that as a subtraction sign because it had started as an addition problem. On the bottom, I get negative 7. Okay, now you could break it down with the factors and you could cancel it, but that just divides. Negative 28 divided by negative 7 is 4. 2 negatives make a positive. Okay, let's start going through here. I got negative 7. I just did the first multiplication there. Okay, this is negative 15. Okay, along the top here, I'm going to do 9 times negative 3 is negative 27. And I'm going to show the sign because we had addition. Down here I got negative 17. Okay, on the top, you owe me and then you owe me again. Okay, again, they keep giving us these ones. This just divides down to 2. Okay, so once again, they're going to give us a little bit of translation work to do with some new things that we've just learned. Okay, so let's go one time. We're going to build a quotient. Well, a quotient, we were doing it like this, but from the rest of on in algebra, we're going to use it as a fraction bar. So the quotient is this fraction bar of the difference of m and n. So that's telling me this is one thing. The comma is helping me as well. This is the 1, the difference of m and n, and p. So this is complicated, but I'm taking the quotient first of the difference of m and n, and the other thing that I'm dividing is p. All right, these are pretty challenging, but again, let me help you through. The quotient of this thing and this thing. So that's the top, and there's the bottom. Okay, the quotient is going to tell me the fraction bar of the sum of q and or p and q, and here's the second thing. So the sum of p and q and r. All right, they didn't give us many of those. Never super easy to work on with, but we start a lot of ideas there. We started with complex fractions. It's just keep, change, flip. We had some expressions that had numerators and denominators now, tops and bottoms. You just clean up the top as if it's its own, please excuse my dear Aunt Sally. You do the bottom like it's its own, please excuse my dear Aunt Sally, and then just reduce any fractions at the end.